Okay, for this problem, you're told that we have a triangle ABC where the side lengths AB is 13, BC is 15, and AC is 14. So there's your triangle. We'll make an observation here that by the Pythagorean inequalities theorem, if the longest side squared is less than the sum of the squares of the other two sides, you have an acute angle right here, and therefore an acute triangle. And that means if we drop an altitude from B to AC, that it will be interior to the triangle, which means we can call this distance x and this distance 14 minus x. And just so you get an idea, if I drop or kind of draw in the the angle bisector of angle B, it'll look maybe something like this. And so we want to find the area of the triangle BF. And if I put a G here, that's what I'm trying to find. Okay. So what we have to do is find some segment lengths here. So over here, if we drop the altitude, and again, talk about it dividing AC into x and 14 minus x, I've got two right triangles. I can use the Pythagorean theorem on each of them. So x squared plus h squared equals 169 for this triangle on the left. And h squared plus 14 minus x, the quantity squared, equals 15 squared, or 225. And from this first inequality, or this first equation, that implies that h squared equals 169 minus x squared. So that's what I substitute here. Excuse me, that allows me to solve for x. Conveniently, the x squareds drop out. I get x equals 169 plus 196 minus 225 divided by 28, which is 5. So this distance is 5, which means this distance is 9. And if you substitute one of those values into, let's say, this first equation, you find out that h is 12. So you have a 5, 12, 13 Pythagorean triple on the left and a 9, 12, 15 Pythagorean triple on the right. Now we're going to work with the angle bisector. We want to get an angle bisector coming down this way and see if we can find out what this distance is so that we can find this distance right here. So there's the angle bisector. And we're going to use the angle bisector theorem, triangle angle bisector theorem. So if you drop an angle bisector to the opposite side, you can set a proportion. This side, AB, is to AC as BD is to DC. So in our case, Y is to 14 minus Y is 13 is to 15. Whoops. These should be Y's, not U's. So y equals 6.5. And that's really all we need to know, because if I put in this altitude, the distance from A to F was 5, which means this distance is 1.5. There's the area right there. 12 is the altitude, 1.5 is the base, or vice versa. So area of a triangle, 1/2 the base times the height. There's your answer right there, 9. Okay? Hope that helped. If you have any questions, post a comment.